this lesson, you will learn about the software-defined WAN feature available on FortiGate. In this lesson, you will explore the following topics: Introduction to Software-Defined WAN, SD-WAN Status Check, SD-WAN Rules, SD-WAN Diagnostics. After completing this section, you should be able to identify use cases for SD-WAN, identify the implementation requirements for SD-WAN, configure SD-WAN virtual link and load balancing, configure static routes and firewall policies for SD-WAN. By demonstrating competence in SD-WAN, you should be able to configure the SD-WAN virtual link and traffic load balancing to use multiple WAN links effectively on FortiGate. SD-WAN is a virtual interface consisting of a group of member interfaces that can be connected to different link types. FortiGate groups all the physical member interfaces into a single virtual interface, the SD-WAN interface. Using SD-WAN simplifies configuration because the administrator can configure a single set of routes and firewall policies and apply them to all member interfaces. There can only be one SD-WAN interface per VDOM. One of the main motivators for deploying SD-WAN is effective WAN use when you are using multiple WAN links. Effective WAN use is achieved using various load balancing algorithms such as bandwidth usage, sessions, or application-aware routing. Another important feature of SD-WAN is link quality measurements. Using ping or HTTP echo, FortiGate can determine the latency, jitter, or packet loss percentage for each link, and dynamically select links based on these measurements. This ensures high availability for business-critical applications. When you configure SD-WAN, you must specify at least 2 member interfaces and their associated gateways. You should configure SD-WAN early during the initial setup of a FortiGate because if an interface is already referenced by a firewall policy or static route, you cannot use it as a member interface. If you intend to use an interface as an SD-WAN member, and that interface is being referenced by a firewall policy or static route, you must delete the associated firewall policy and static route before you can assign that interface as an SD-WAN member. SD-WAN supports physical interfaces as well as VLAN, aggregate, and IPsec interfaces. When you enable SD-WAN, you must specify the load balancing method. SD-WAN load balancing uses traffic distribution methods that are similar to those used by Equal Cost Multipath, ECMP. However, SD-WAN link load balancing includes one more balancing method: volume. SD-WAN link load balancing uses these methods. Source IP. Traffic from the same IP address uses the same link. Source destination IP. Traffic from the same pair of source and destination IP addresses uses the same link. Spillover. This method is similar to the spillover method used by ECMP. A link routes all the traffic until the volume reaches a threshold. After that, another link is used. Sessions. The interface weights determine the proportion of sessions that each link should handle. Sessions are distributed among the links based on the interface weights. Volume. The interface weights determine the proportion of traffic volume that each link should handle. Sessions are balanced so that traffic volume is distributed based on the interface weights. After you have enabled SD-WAN and configured the member interfaces and the load balancing method, a logical interface with a name SD-WAN is automatically added to the interface list. Next, you must create the routes and firewall policies using this virtual interface. You must still configure a default route when implementing SD-WAN. The default route configuration using the SD-WAN interface does not require a gateway address because FortiGate will forward packets to the appropriate gateway based on the member interface gateway information. When using SD-WAN, you do not need to configure multiple firewall policies for individual member interfaces. Firewall policies created with the SD-WAN interface allow traffic to be forwarded through any member interface. Even though you must configure routes using the SD-WAN virtual interface, FortiGate installs individual routes for the member interfaces in the routing table. These routes share the same attributes, destination address and subnet, distance and priority, and are both active. This allows FortiGate to remove individual routes in the event of an interface outage and redirect all traffic to the remaining member interfaces without affecting the whole SD-WAN load balancing group. Good job! You now understand the SD-WAN feature on FortiGate. Next, you'll learn about the SD-WAN status check and link quality measurements. After completing this section, you should be able to configure the SD-WAN status check, identify how FortiGate measures link quality. By demonstrating an understanding of SD-WAN status check, you should be able to configure SD-WAN status check and identify how FortiGate measures link quality. For load balancing to be effective, there needs to be a constant monitoring of the health and status of the links that make up the SD-WAN link. FortiGate can check the status of each SD-WAN member interface. If SD-WAN status check is configured, FortiGate periodically sends packets to the server through each of the links. If the number of consecutive packets sent to a link with no reply goes above the failures before inactive threshold, that member is removed from the SD-WAN load balancing group. SD-WAN status checks are used by SD-WAN rules. Depending on how you configure the rule, the status check can apply to individual member interfaces or the SD-WAN group as a whole. SD-WAN status checks also measure the quality of the links connected to each member interface. 3 different criteria are used for this measurement: latency, jitter, and packet loss percentage. These link quality measurement checks can be used by SD-WAN rules to dynamically route traffic based on the quality of each member interface. You will learn more about SD-WAN rules later in this lesson. SD-WAN status check allows FortiGate to dynamically deactivate and activate routes based on link availability. If status check reports an interface is inactive, the corresponding routes will be removed from the routing table. If multiple status checks are configured, all need to report an interface is inactive for the route to be removed. If you choose to configure only one status check, you should be aware of the risks of false positive events. For example, if the server you are using in the status check configuration experiences an outage, but your ISP link is operational, it will cause unnecessary traffic disruption in your network. To reduce false positive events, it is recommended that you configure multiple status checks with different servers. This ensures that the affected routes are only removed if multiple servers are unreachable using that interface, which can mean that your ISP link may be experiencing issues. The CLI commands for configuring status check provides more options. The TCP echo, UDP echo, and TWAMP options are only available on the CLI. These options provide different methods of measuring round-trip network performance between any 2 devices that support them. There are other CLI-only options that are available only based on the status check protocol you choose. For more information on these options, refer to the CLI reference guide on docs.fortinet.com. You can also configure the warning and alert thresholds for the latency, jitter, and packet loss quality checks. These are also not available on the GUI. Good job! You now understand SD-WAN status check. Next, you'll learn about SD-WAN rules. After completing this section, you should be able to identify SD-WAN rule matching criteria, configure dynamic link selection based on link quality. By demonstrating competence in SD-WAN rules, You should be able to configure dynamic link selection based on link quality to ensure high availability for business-critical applications. SD-WAN rules allow you to specify which traffic you want to route through which interface. You can configure the SD-WAN rules to choose the egress interface based on a link's latency, jitter, or packet loss percentage. The rules are evaluated in the same way as firewall policies, from top to bottom using the first match. The following parameters can be used to match the traffic: source IP address, destination IP address, destination port number, ISDB address objects as destination, users or user groups, type of service, TOS. SD-WAN rules offer great flexibility when matching traffic. For example, you can route Netflix traffic from specific authenticated users through one ISP, while keeping the rest of your internet traffic through another ISP. Similar to ISDB routes, SD-WAN rules function as policy routes. They take precedence over any other routes in the routing table. Good job! You now understand SD-WAN rules. Next, you'll learn about SD-WAN diagnostics. After completing the section, you should be able to monitor SD-WAN link usage, monitor SD-WAN link quality status, verify SD-WAN traffic routing. By demonstrating competence in SD-WAN diagnostics, you should be able to maintain an efficient and effective SD-WAN solution. You can use the SD-WAN usage monitor to view traffic distribution between the member interfaces based on bandwidth or volume. The volume view gives a better representation of the sessions being load balanced across all the member interfaces, whereas the bandwidth view shows you how much bandwidth each interface is using as a result of the sessions passing through them. Since link quality plays a big role in link selection when using SD-WAN, monitoring the link quality status of the SD-WAN member interfaces is a good practice. Any prolonged issues with packet loss and latency should be investigated to ensure your network traffic does not experience outage or degraded performance. Green arrows indicate interfaces are active in the SD-WAN group. Red arrows indicate that the interface is inactive for that specific status check. FortiGate will also generate system event logs when an SD-WAN member interface's route is removed from or added to the routing table. Use System Events log menu to investigate the reasons for any route failovers. You can use the Destination Interface column in the forward traffic logs to verify that traffic is egressing the SD-WAN member interfaces. Alternatively, you can use verbosity levels 4 and 6 to view the egress interface using the CLI packet capture tool. Congratulations! You have completed the lesson. Now you will review the objectives that you covered in this lesson. This lesson covered the following objectives: identify use cases for SD-WAN, identify the implementation requirements for SD-WAN, configure SD-WAN virtual link and load balancing, configure static routes and firewall policies for SD-WAN, configure SD-WAN status check, identify how FortiGate measures link quality, identify SD-WAN rule matching criteria, configure dynamic link selection based on link quality, monitor SD-WAN link usage, monitor SD-WAN link quality status, verify SD-WAN traffic routing. By mastering the objectives covered in this lesson, you have gained the skills and knowledge that you need to configure, maintain, and diagnose your FortiGate's SD-WAN solution.